to start off our logarithms chapter, we're going to be looking at roots and radicals. And that's to start us off because in order to understand exponentials, we need to understand roots. We need to understand radicals. Roots and radicals are very, very similar. A radical is just a square root sign. In this case, it is a square root, but you could have a fourth root. Okay, so it just kind of depends. So what is a root? A root is where our graph or our function is going to be 0. Okay, so this is where we're actually crossing our x-axis. Okay. There are potentially imaginary roots, and we'll talk about that later on, not in this unit, but a different unit. So for instance, if I were to have this graph here, looking at this graph, I have 3 roots. I know that because that's how many times the function crossed the x-axis. Okay, as you can see, I just pinpointed those roots. Some of you might be asking, how do I determine the number of roots without looking at a graph? You can determine that by looking at your exponential. Okay, and this is where this ties in. So this is going to be, let's say it's x cubed minus 5x squared plus 4. Now I don't really know if that's the true picture of that function. I just drew that up there, but I'm giving you an example here. So with that, you look at the highest exponent degree, and that's how many roots you will have. So we've got 3 roots because the degree is 3. However, like I said, some of these might be imaginary and they are not true roots. So write this down. Some roots may be imaginary and will not show on the graph. These are what we call non-real roots. So the picture above where we can actually physically see those 3 roots, those would be real roots because they are visible. Something to note is our exponents and this is an exponents rule, it might be something that's unfamiliar or you might have just forgotten about, but when you see something that's in parentheses and it has an exponent and then you're going to raise it to another power. So let's say I've got x to the 4th squared. Okay, so realistically, this is not x to the 6th. This is x to the power of 4 times 2. So this is really x to the 8th, which would tell me that I've got 8 potential real roots. As well as it's not to the 6th. I know this can be kind of confusing when you're talking about exponents and all of those different rules, but it's just a good rule of thumb. If I were to have x to the 4th times x squared, notice I'm not taking that x to the 4th to the power of 2. This I just add the exponents. This right here is x to the 6th. The reason why I'm showing you this is because if you're trying to figure out the number of roots and you've got situations where you're taking something to a power or you're combining like terms such as the second example there, you need to understand how many exponents or how many roots you really actually have based on those exponent properties. Okay, so last but not least is the tie into the radicals. How does that actually fit with us? Okay, so a radical is where we have the n root of x. Realistically, you can write any radical as an exponent. This really is x to the power of 1 over n. Okay, and to kind of give you an example here, let's say that I have the square root of 25. Okay, so we know right now that that's going to be 5. We already know that. But just as good measure, 25 to the power of 1/2. Now, if I were to actually type this in on a calculator, which I don't think I have that option on here, well, the calculator on here is the most basic one that won't take it to a power. But you can do this yourself, is take 25 to the 1/2, and that is going to equal 5. Now, technically, this is plus or minus 5. Don't forget that. So that's how a radical ties into the roots. Just because you're taking it to the power of 1 over n. So just so you guys can see an example of what you will be doing on your homework and that kind of stuff, they will be asking you to simplify your answers. So for instance, if they ask for the 4th root of 625, this is really 625 to the power of 1/4. So how exactly do you do that? Well, I actually do it a little bit of a flip. Here's how I do it as a flip. Okay, so I know it's going to be something to the 4th. So I start with 2 to the 4th, and that actually equals 16. Okay, 3 to the 4th. It's not going to equal that. I'm just going to tell you that now. 4 to the 4th. Still not going to equal that. And then until I find the actual one that gives me 625, I start at 2 and then I work my way up. You can use a calculator. I'm not too worried about that. I don't expect you to know what the 4 to the 4th is, because obviously I don't know that off the top of my head. So use a calculator. It's no big deal. If they ask you to do it by hand, this is what I would do, is just the reverse. I know it's supposed to be the 4th, so I took 2 to the 4th, 3 to the 4th, 4 to the 4th, 5 to the 4th to know that it was 625.